Hello, I am Karim Khalid Noman and this Plaxis 2D 3D course. Now we are in chapter 7 Shallow Foundation. We will model this example on Plaxis. We have soil profile. We have 4 layers as follow. Layer 1 silt clay, its thickness 3 meter, angle of internal friction is 35 degree, cohesion 3 kilopascal, modulus of elasticity 1850 kilopascal, soft clay, the thickness is 3 meter, angle of internal friction 30 degree, cohesion 1.5 kilopascal, modulus of elasticity 1220 kilopascal, clay-1. The thickness of layer 3 meter, angle of internal friction 32, cohesion 4.5 kilopascal, modulus of elasticity 2000 kilopascal, sand 1.5 meter, 30 degree, 0.5 kilopascal, 30 triple 0 kilopascal for modulus elasticity. Water level, initial water depth 4 meter below existing ground surface. Distribution load, point load for isolated footing 50 kN and point loads for strip footing B1 equal 60 kN and B2 equal 40 kN, and live load equal 200 kilopascal for raft on soil. Okay, in this example we will model 3 different of shallow foundation on the same soil profile. You will see isolated footing beside strip footing beside raft on soil. Okay, and this is our system: isolated footing, strip footing, raft on soil. The required is total stress and displacement for the soil, internal forces on isolated footing and strip footing and raft, factor of safety for my model. So we will open the Plaxis. The title of my model, I put it Shallow Foundation. Okay. The model is plane strain. For isolated footing there, I hold it and okay, we should zoom. Okay, we click on it like that and hold it and put it sliding. The definition is correct. Okay, for strip footing, like isolated footing, sliding, okay. We will define the raft as you see. Okay, so we define the material of my foundation and return to soil and interface to define my layer. My first layer is silt clay, and the second soft clay, and the third clay-1, the last layer. Okay, my last layer is sand, and press apply and okay. Then we will define the loads on isolated footing you will see the contours here and relative shear. You can benefit from it in your reinforcement, in your steel reinforcement shear for the bending moment here equal minus 20.30. Your isolated footing here equal minus 19.51, and shear force here. I wish you all enjoy in this chapter, and goodbye.